Hi. In this lecture, I will show you the easy way to use Radare. I tried to hide it from you until the last step, but now I have to give up my secret that there is actually a graphical user interface for Radare. The reason I talk about this at the end of the course is that I really think that one should learn first how to use the core Radare UI, which is a terminal. Alternative UIs come and go, as they did in the past, so the most dependent is the terminal. And the big advantage of Radare is that you can use it on machines even if the machine doesn't have a graphical interface, such as embedded devices. For instance, you could use Radare on an iPhone. But after this lecture, you can decide for yourself which UI you like, the terminal or this one. So let's get started. The graphical user interface that we're going to use is called Cutter. And here's the GitHub page. And the Radare.org Cutter. You see, it looks pretty fancy. This is open source, so you can either download the source code and build it yourself. You can download the pre-built version and install that. For this exercise, I'm going to use a Windows machine because the binary that we are going to test runs on Windows. So you can use any Windows machine you have. Of course, I'm using a VM. But if you don't have a Windows VM, then you can download it for free from Microsoft. There is this website here. And here you can download various versions of Windows. I use the MS Edge on Windows 10. You will have to install two things, the 7-zip and the Visual C++ redistributable package, which is free again, so that shouldn't be a problem. So once you have your Windows up and running, just come to the GitHub page and here to releases and download the Windows 64-bit version of Cutter. I've already downloaded it. Once you have it, you just unzip it, and then you just start the cutter.exe. If you get an error message here, then again, you will have to install the Visual C++ redistributable package. All right, now we will have to have something to play with. For that, I'm going to use a challenge from the 2018 FLAREOn challenges. If you don't know FLAREOn, it's a yearly challenge from Flare, which is the reverse engineering team of FireEye. It's pretty cool, but it's also pretty hardcore. So if you come to FLAREOn.com, then you get this nice terminal. Then we go into past results. Here, 2018. And here, downloads. And then just download this file. I've already downloaded this one as well. So I have it here, downloads, and extract it. And once it's all extracted, we're gonna use the 03 FLAGO challenge. So just unzip it. That's why we need the 7-zip to be able to unzip this one. And let's say extract to FLAGO. And the password is infected. So these are not really malware, but some of the challenges are based on malware. That's why they are encrypted. And that's also the reason why we are using a virtual machine to play with these. But don't worry, FLAGO is a simple challenge, so there shouldn't be any problem with that. I will also turn off Windows Defender because it might get triggered. So if you search for Defender, let's go to Windows Defender Security Center, go to Virus and Threat Protection, Virus and Threat Protection settings, and turn these off. I hope it's enough. All right. So as I said, we are going to work with 03 FLAGO. If you go to challenge description, open with Notepad, and you can scroll down, and here's the description of the challenge. As you can see, it kind of gives you a hint. It says it's a child's play, and it's called FLAGO. So, you know, something might be there, but we will see. If you go into the folder, there's another zip file, so we need to unzip this as well. Extract here. And as you can see, it's gonna give us a bunch of binaries. So at this point, we need to figure out what these binaries do and what we should do with them. So first, let's try to run them. PowerShell, I will open a PowerShell, and let's go to downloads, and here Flare, and then 03, or yeah, sorry, and then 303, and let's start with the first one. So it's something 1B something or other. So we are going to execute the first binary, which is 1BPN something or other. Enter, and it asks for a password. If it doesn't do anything for you, then probably you didn't install the Visual C++ redistributable x86 version. So again, you can just download it and install it. So what happens, these binaries are 32-bit binaries. So if you only install the 64-bit version of the Visual C++ redistributable, then these binaries will not gonna run. So just install the x86 version as well. But if it works, then it asks you, what's the password? Obviously, we don't know the password, so I will just type in something, and it says, go step on a brick. So we didn't get too far, but it gave us a few things we can start looking at. We pretty much want to find out some kind of password. We know these two strings, what is the password, and go step on a brick. So let's go to Cutter, open this binary we executed now. So I go to select, and the downloads, not Cutter, FLAREOn challenges, FLAREOn, FLAGO, and then the first one, and then open. So as you can see, it's gonna do AAA first to analyze the binary. So okay, and it's done. So this is the main interface of Cutter. What you see should be partly familiar. On the right side, we see the disassembly as we are standing at the entry point. And on the left side, we basically see the functions list. And here at bottom, we have various views. So if you go to the dashboard shows general information about the binary, which we usually see when we do the I command. So just a few things, as I said, it's a 32-bit binary, it's a PE executable, it is stripped, so we are not gonna see useful function names. Here we can also see the loaded libraries, which is not super useful at this time, but in many cases, it could give you a really good hint about what are the capabilities of the binary. So if it loads libraries which deal with networking or something like that, then that basically means that the binary will actually do probably some kind of networking. So the disassembly view is very similar to what we saw in the terminal's visual mode. Then if you go to the graph mode, it's a nicer representation of the block diagram we have seen in the terminal. Then the hex dump is basically the plain hex dump of the binary. Strings is obviously the list of strings in the binary, which we are going to use. Import shows us the imported library functions, which is again also very useful because you could see what kind of functions are used in the binary, and that could give us really good hint what the binary does. And it can also start our reverse engineering process. For instance, if you look at here, it uses somewhere the isDebugger_present function, so probably it implements some kind of anti-debugger functionality. The search tab is pretty easy. We can search for things here. We can search for assembly code, strings, hex strings, drop gadgets if you are writing an exploit. Jupyter is something we're not going to use now, but it's kind of collaboration framework. All right, now that we got to know this very complicated user interface, we can go back to our questions. Basically, what is the password and how to get this binary working. So first off, as I said, let's start with the strings. We know these two strings, what is the password, and go step on a brick. So we'd like to find out where the password is actually checked in the code. So if we go to strings, let's start looking through. The beginning is not really useful, but later, brick, that could be useful. Iron Man sucks, hello Batman, and then here, what is the password? So, and here we see also go step on a brick. So this could be useful. So for instance, if we double click this string, then we will get to the point where it's stored in the binary. As we did it in the previous lectures, if we push X, then we get the cross references, basically where this string is used in the code. So there is only one use, so let's jump there. And as you can see, it pushes the string on the stack and then calls this function, which is probably the function which is actually gonna print the string on the terminal. If we go to the graph view, then we get a better look. So here we write the question, and then something happens, then the Iron Man sucks function is gonna be called, and then after that there is basically an if. In one case it go step on a brick, in the other case it goes somewhere else. For instance, we can get to rainbows, so that sounds good. But the point is that something happens here, so maybe the password is checked somewhere here. My assumption would be that this is where we print the question, this is where we read the answer, and then here's going to be some check done, and based on the result of the check, we either go to the error state or continue wherever. So let's go into this Iron Man sucks function. So if you double click it, you get to the entry point of that function. So as you can see, the first instruction will load the string Iron Man sucks into EDX. After that, some things are happening. Now, this string kind of looks like a password, so we could just test it out before we go into what exactly happening in the assembly. So I go back to PowerShell and execute the binary again. So the password might be Iron Man sucks, right? And it says, oh, hello Batman, go step on a brick. So it doesn't seem like the right password because it didn't really do anything useful. We somehow got further in the code, but still got into a similar error state. So if we look at this code, EAX has probably the input string, so what you type in, and EDX has the string Iron Man sucks. So here we take basically one character from EAX, so the input string, and compare it to the first character of EDX. And then if they equal, then we check whether that character is a null character. And then this part is gonna iterate the string to the next character and jump back to the check. So basically what's happening here is that we are iterating through each character in the password string as well as in the Iron Man sucks string. And probably at one point we'll get, if it equals, then we get here to, oh, hello Batman, and we return to this function. This is the scenario what we have seen in PowerShell, that our password was Iron Man sucks, and it just prints this additional string, otherwise it exits. Now, but if we look at here, we see that there is another case which could be interesting. If we zoom out a little bit just to have like an overview, you can see pretty well that just from how the graph view looks like, that it's pretty much the same. So here we are comparing the input password to the string Iron Man sucks. If it equals, then we are exiting here. If it isn't equal, then we go to this branch, and we're gonna do a very similar thing here. So probably we are again comparing some string to the input string. So if we zoom back in, by the way, I'm zooming with Control and Scroll. You see that here again, we move something from this address to EAX, and then we take the first character from ECX. ECX is created here on the top. So again, that's probably the input string, and compare it to EAX. And then again, we are iterating through each character, and then we either end up here, doing something, or here doing something. But the point is, we don't have to understand each instruction. You could sit down and understand each instruction, but the point is to figure out what it does, not what each instruction exactly do. But what looks interesting for us is this memory address, because the real password might be at this memory address when the code is executed. And that's what we are comparing to our input stream. If we go there, just double click it, we see that it's not too useful. If we go to a hexam, you could see that it's all zeros. So let's navigate back. So my assumption is that when the binary is executed, the password somehow will get to this memory address. Once the execution gets here, this is where the password is compared. And then based on the comparison, either it's the good password or not. So we'll need to figure out what's at this address in runtime. There are multiple ways to do it. You can start the application in a debugger and put a breakpoint here to see what is there when the actual comparison happens. You might have some difficulties with the debugger because, as we could see, it uses some anti-debugging features. But if you really want to try it, I would go for OllyDbg2 because it has some anti-debugging features as well. However, we don't necessarily need debugger here because we could just find that statically in Radare2. All right, so first double click the memory address again. And here I'm gonna push X to look for cross-references. Basically want to find out when this memory address is populated with the password. So I do X. We are in luck. It's not used too often. So first, if we go into this one, then we could see that is used as an argument of memset. So if you want, we can Google memset. And it's going to tell us that sets the first num bytes of a block of memory pointed to pointer to a specified value. And the specified value is 0. And basically what this does is initialize memory. So we're going to initialize this memory address with all zeros. So this is fine, but this is not what we are really looking for. So I will just go back and back. And then let's look at the cross-references again. And then this one is here. It's the same function where we found this memory address, so that's not too interesting. So let's go to the last one. I will jump here. And as you can see here, the memory address is used as the argument of memcopy function call. This looks really good. If we search for memcopy, then it will tell us that it copies a block of memory, and the first argument is the destination address, the second is the source address, and the third is the size. So basically it copies data from one place to another, and if we go back to Cutter, we see that our memory address is the first argument, which was the destination. So that's great. So this is where we copy something to the address where the password is supposed to be. And then the second argument is the source, which is here EAX. So we need to find out where is EAX coming from. So right now I'm pretty sure that this is the right function where the password is created. So I will rename this function and call it set password. So EAX usually contains the return value of a function. And as you can see at the very beginning of this set password function, there's another function called. And if we navigate into that, then we'll see that a few things are happening here. I will again rename this function because I'm hoping that this is the place where the password is looked up. So I will call it get password. And as you can see in this function, it calls the find resources W and then load resource, log resource, size of resource, etc. So it does something with resources. So resources are parts of the P executable. So it's one part of the binary. And the find resource API function is going to return a handler to the resource. And the resource name is here the brick. It's loaded from here. The string is brick. So we are looking for a resource that's called brick. If you don't know these functions, I really recommend you to Google them to know exactly what it expects and what it returns. The load resource function returns a handle to the contents of the resource. And finally, the log resource function will return the address of the first byte of that content. So after this one, we have the memory address of the content of the brick resource in EAX. And then here, EAX is saved in ESI. And then here, ESI is returned back to EAX. So that's what we are going to return. So just to recap, find resource is going to look for a resource which is called the brick. Load resource takes a handle for the contents of that resource. Log resource will load the memory of the address of the first byte of the resource content. And that's what we are returning. So basically the password is loaded from a resource in the binary called brick. We can find these various ways. If you open the sections window, so if you go to Windows, you can see that not everything is here at the bottom by default. So we can go to Info and then here look for a window called Sections. Open this one and it opens up another window here at the bottom. And then these are the sections of the binary. And there's a section called .rsrc, which is the resource section. So we can double click it and then look it at in hexdump. And then we can immediately see that there is a brick and then there is something afterward, which looks really like a password. But another way would be to, again, go to Windows and Info and Resources. Here it's going to give us unknown, but if we double click it, then we get the password again. To be able to properly copy paste the password, I will just copy the address of it in memory and then go to console. I will just print this from the memory. Yeah, this way we don't have to deal with the 0 bytes in memory. So I will copy this and go back to PowerShell and execute the file and paste the password. And it says everything is awesome. It dropped some kind of PNG and points to W. So let's look at the image. So if we go back here and there is the PNG and we can open it with photos. And as you can see, and now we can understand why the challenge is called FLAGO. This is a Lego figure and there is some kind of serial number here. So we'll figure that out later what all this means. But the point is that we got an image with a serial number and it's associated with a letter. All right. My theory is that the image is from Lego assembly manual and that if you find a password for all these bunch of binaries, then they will drop different images. And if you organize the images in the order of the numbers on the images, that will give us the associated letters in the right order, which is probably going to be the flag for the challenge. And what we know about the passwords is that it's always at the resources section under the resource called brick, and then there is the password. You can open up a couple of other binaries to confirm this theory. I'm not going to do that right now. So basically what we want to do is you could do it manually to extract the password for all these binaries and execute them to dump the images. but a better way, I think, is to automate it. So we would like to write some kind of script that finds the password in each binary, then executes the binary with the password. So at this point, I just want to tell you, we are basically finished with the part where we used Cutter. So I hope you found it useful, and Cutter as well as Radare is a pretty cool tool. You can decide now whether you prefer Cutter or whether you prefer the terminal version of Radare. But even if you work with Cutter, just keep in mind that whenever you work on an embedded device or something and you want to work on the device, then you can still use Radare with the terminal UI. We're going to take a short break now and finish up the challenge in the next lecture. So see you there. Bye.